So, the Fibonacci sequence. In mathematics, the Fibonacci sequence is a sequence in which each number is the sum of two preceding numbers that are part of the Fibonacci sequence, known as Fibonacci number, commonly denoted f of n. The sequence commonly starts from 0 and 1, although some authors start from the sequence 1 and 1, or sometimes as the Fibonacci from 1 and 2. Starting from 0 and 1, the sequence begins 0, 1, 1, 2, 3, 5, 8, 13, 21, 31, 59, 89, 144. And to answer the question, yes, I totally did read of the definition out of the Wikipedia. See, it's open right here. So, but yeah, the definition. Here you have all the numbers. But what is Fibonacci sequence really? How do I actually calculate it? For that, we're gonna use this. You can see we have f of 0 and f of 1 as the base cases, because f of 0 is 0 and f of 1 is 1. And the formula is f of n is equal to f of n minus 1 plus f of n minus 2, which doesn't mean that Fibonacci of 5 will be 4 minus 3, but it will be Fibonacci of 4 minus Fibonacci of 3. Let me show you through paint here. This is brighter than I expected, but well, first I will write here the Fibonacci of 0 equal to 0 and Fibonacci of 1 equal to 1. This is the base case we have here. That will be very useful. Now, first let's try to calculate Fibonacci of 5. That will clearly explain how to actually calculate Fibonacci and how it actually works. So Fibonacci of 5, it will be split into two parts. Fibonacci of 4 and Fibonacci of 3. Why? Because 5 minus 1 is 4 and 5 minus 3, 5 minus 2 is 3, because we have the formula here. Fibonacci of 1 is equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. This is the general formula for Fibonacci. Now, will it stop here? No, because this Fibonacci of 4 will again get split. We'll have Fibonacci of 3 plus 4 minus 1, and we'll have Fibonacci of 2 because 4 minus 2 is 2. Then Fibonacci of 2, this will again get split. We'll have Fibonacci of 1, which is 2 minus 1, and then again we'll have Fibonacci of 0. Now this tree right here, it will stop right here. Why? Because it has reached all the base cases 0 and 1. Everything is made up of 0, 1 and 1 here. Fibonacci of 0 and 1. But this Fibonacci of 3, this will keep going. It will first become Fibonacci of 2. There we go. And another branch will become Fibonacci of 1, because Fibonacci of 3 minus 1 is 2 and 3 minus 2 is 1. This branch, it will stop right here, but this branch will keep going. It will become Fibonacci of 1 and Fibonacci of 0. Now, everything on this side of the branch, of this side, it has all been turned into Fibonacci of 0 and 1, so it cannot go any further. But this side, well, let's start with this side. It will be just a copy of this one, Fibonacci of 3. So it will first become Fibonacci of 1, and then 1 will become Fibonacci of 2, because 3 minus 2 is 1 and 3 minus 1 is 2. But this is done because Fibonacci of 1 is just 1. A base case has been reached. Fibonacci of 2, this will become Fibonacci of 1 and Fibonacci of 0. Now it will again stop because a base case has been reached. Since all the base case has been reached, then it will stop. So you can see that each is breaking into their own Fibonacci. 5 will become 4 and 3, 4 will become 2 and 3, 2 will become 0, 1, 3 will become 1, 2. And then what happens? Now we are gonna have to calculate the sums. The Fibonacci of 0 will be 0. The Fibonacci of 1 will be 1. So 0 plus 1. The Fibonacci of 1 will be 1. The Fibonacci of 1 again will be 1. The Fibonacci of 0 will be 0. Then this Fibonacci of 1, it will become 1. This Fibonacci of 1, well, as you guessed it, this will become 1. And then plus, last but not the least, this will become 0. As you can see, all of them has been broke into their base cases, which is 1 and 0. Fibonacci of 1 is 1, Fibonacci of 0 is 0. Now we just got to add this up. Zeros don't count, so we just got to look into how many ones there are. We can see this is 1, this is 1, this is another 1, this is another 1, and this is the last one. But important, because if we miss one step, it will give the wrong value. How many ones do you see in this whole part? There are 5 ones, which means this is gonna equal to 5. So from that we can conclude that Fibonacci of 5 equals to equals to 5. So the fifth sequence in the Fibonacci is 5. And if we go from here, you can see that it is 5. Is the first one that is starting. It is not Fibonacci of 1. This is the 0th Fibonacci. This sequence starts from 0, not 1. So 0, 1, 2, 3, 4, 5. You can see that the Fibonacci of 5 is 5. So yeah, this is how a Fibonacci is calculated. It's like a whole big tree. To be honest, it is quite satisfying to look at how a Fibonacci is conceptually formed and actually calculated. Now, if you go to a code, this is how a Fibonacci is made in a Python function. It uses Fibonacci as recursion. You can see that Fibonacci of 0 is a base case, as we saw before. I'll open them side by side for convenience. So here Fibonacci of 0 and Fibonacci 1 is a base case. As you can see here, the Fibonacci of 1 and Fibonacci of 0 are base cases. Then else Fibonacci of x minus 1 and x minus 2. So how is this working? Let's take Fibonacci of 3 for example. This will get broken into, as you can see, Fibonacci of x minus 1 and x minus 2, which will be equal to Fibonacci of 2 plus Fibonacci of 1. This side is complete. Alright, because the base case has been reached, which is 1, and it will return 1. And it will return 1. Alright, it will become 1. But this side is still not complete. So this will become Fibonacci of 1 plus Fibonacci of 0 plus here we have 1. Alright, well, from the previous. And Fibonacci of 0. What is Fibonacci of 0? Fibonacci of 0 is just 0. So this whole will become 0. What is Fibonacci of 1? Just 1. So what is the final output? The final output will be 1 plus 0 plus 1, which is 2. And let's verify. Fibonacci of 3 is 2, which is correct. That's how this Fibonacci is formed. But why did I tell you all this? Just to tell what Fibonacci is? Well, no. As you can see, if we look here, the Fibonacci of 5 equals to 5. And as we calculated 2, the Fibonacci of 5 is equal to 5. We calculated it right now, right? So, from here, why do we actually use Fibonacci of 0 and Fibonacci of 1 as base cases? Because Fibonacci of 0 equal to 0 and Fibonacci of 1 is equal to 1. So their input is the same as their output, which is the same case with 5. The input is the same as the output. So what can we conclude from here? We can use Fibonacci of 5 as a base case, and it will return the correct output. This I will explain later, but for now let's copy it, create a new file. Let's name it fib.py. I'll paste it, change it a bit. We'll do print Fibonacci 15. Let's take for example. This is a normal method, alright? Taking 0 and 1 as base cases. Right, what's going wrong? Did it just show an error? Unexpected indent? What? Alright, it was just an wrong error. We can see from here Fibonacci of 15 is 610, and let's also calculate Fibonacci of 20. Why not? I'll have to input 20 here as the input, and we'll get 6765. Well, let's actually write it. We got Fibonacci of, right, that's not the comment. We got Fibonacci of 20. We got it equal to, what was it, 6765. There we go. And before we calculated Fibonacci of 15, which is equal to, again I actually forgot, so let's just calculate it. I think it was 670, 610 actually. Would you look at that? Fibonacci of 15. We can see that Fibonacci of 15 is indeed 610. So it is showing the correct output. Let's also calculate Fibonacci of 19. Why not? It's causing no harm. Fibonacci of, let me copy and paste it. Fibonacci of 19. Alright, let me run it. Fibonacci of 19 is 4181, which is the same as here. So let me just copy it and paste it. Now for the main point of this, I will put Fibonacci of x equal to 5 as a base case. Return 5. Now let's see if it will indeed uh, show the correct output. The Fibonacci of, let's start with Fibonacci of 19. The 5 is the base case. 4181, it is correct. Now Fibonacci of 20, let's calculate it. 6765, it is indeed correct. Then Fibonacci of 15, right? Let's do that. We get 610, which is again indeed correct. So we can see that this outputs the correct values. So yeah, as you can see, Fibonacci of 5 can be used as a base case in the recursion Fibonacci function. Well, now for the main point of the video. Why did I tell you all of that? Because I could? Well, that's one reason, but not the total reason. Here, I have made a similar function, but this one times the Fibonacci of 14 or Fibonacci of 40. Why 40? Because it gives enough time for accurate calculation. The higher the number, the more the accurate it will be. So each this calculates the Fibonacci of 40 and provides the time. And as you can see, and provides the time and writes in folders. And as you can see, I have two files here. All right. These are the times that I have recorded. This file is 2 base case, which is 1 and 0. When you use only 0 and 1, it takes 16 seconds for each of the function, and I've calculated it 20 times just so the calculation will be fair and as accurate as possible. You can see that it took 16 seconds for each operation, and with 3 base cases, which means each with 5 as a base case. This took only 6 seconds. It shaved off 10 whole seconds. So, as you can see, setting Fibonacci of 5 is also functional because it significantly reduces the runtime, which if we have some a big program that uses Fibonacci, it will decrease the runtime and it will make your program faster, which is actually functional. All right. So I'll be back in a bit after doing some calculations. By that I mean I'll find the average of each of these. Alright, so I have returned with the calculation. So you can say for the one with three base cases, meaning 5 as a base case, the average time is 6.40511679649353 seconds. And for two base cases, means only 1 and 0, the time is 16.07899124622345, which is, let's calculate how many percent faster is it. Right, so here we have the calculator, the OG. Let's input the number 16 point. There we go. That is the first one. Then we're gonna have to subtract the lower value, which is this. Subtract. Alright, it has been subtracted. We got this value. We're gonna have to divide it with the old value. There we go. We got this value. Now to get the percentage, we have to multiply it by 100. Now how much faster is it actually? 60.164685094918893. It is this much percent faster. I'm gonna write it down right here. Commented. This is this much percent faster. 60% is a huge improvement, I will tell you. And it's not just in Python. This I got the same 60% result in C++. So we can see this is actually a big increase. 60%. But of course, this is only for convenience and a bit of time sharing. By 60%, this does using 5 as a base case does not explain what Fibonacci is. This is what actually Fibonacci is, the concept of Fibonacci. This is the real concept of Fibonacci. But using 5 can serve as a great tool because Fibonacci of 5 equals to 5, just like Fibonacci of 0 and 1. So if you ever need to calculate long programs with Fibonacci, then use as many base cases as possible to make the program faster, or use cache. You can do whatever you want. There are many ways to make a program super fast. This was just something I found that I wanted to show. So yeah, that was it for the video. If you got to learn something new or just enjoyed it, maybe consider giving it a like and subscribe. I will see you in my next video. Bye bye.